Okay, so what we're looking at now is Oersted's principle. This is the practice sheet. So what we have is the first question is, what is Oersted's principle? And again, it's really important just to keep writing these things down just to get the extra practice. Now, I'm not very good with this pen, so just bear with me. So what is it? Well, it is basically when electricity flows through a conductor, in this case a wire, in most cases a wire, a magnetic field is produced around the wire. Okay, so when electricity flows through a conductor, a magnetic field is produced around the wire. So conventional current flow is when electric charge flows from a positive terminal to the negative terminal. Now we know that this is not correct. We know that this is what we call conventional current flow, and but we use that anyways just to make life easier. So in the following diagram of a battery, label the positive terminal and the negative terminal. So the negative terminal and the positive terminal are labeled here. So it's really important to understand that, and then the electricity would flow from positive to the negative. Okay, let's start our drawings and see how we can do this. I'm going to make this a little bit thicker, maybe change the color up a little bit. Okay, so what we have now is the situation where we say draw magnetic field lines. Okay, draw the magnetic field line around the current carrying conductor. So we use our right-hand rule, and we see that the current is flowing in this direction. Our thumb points in the direction of the current, and our fingers curl around the wire. So when we do that, when we put our hand there, we see that it curls around in this direction, around in this direction, around in this direction. And we always label it B vector for the magnetic field. For this one here, the current, again, put your thumb in the right direction. And if you notice what's happening, you can wrap your hand around and your fingers will go. Again, I can't draw all of the, okay, so that's good. Now you go here. Oh, here we've got a conductor where it's pointing into the page. Remember the X is the arrow flying away from us. So this is a conductor that's in 3 dimensions coming out, like it's a wire that's coming towards you or away from you. It's just a wire that's stuck in the page. And you'll see here that it is an X, meaning that it's going into the page. So we put our thumb down into the page and wrap our fingers, and you will see that it will go in this direction. Like that. Okay, so that's the direction of the flow of the magnetic field that's around that one. Okay, so you can check your work. This one's coming out of the page. So, so when I curl it, my fingers do that. These are clearly not even circles. Okay, so you can use your thumb and check that. Now here we've got another one. The current is going to the in this direction here. We wrap our fingers around, and the situation looks like this. Okay, so check your work, see if you got it correct. Okay, now here it says indicate the direction of the current flow. Okay, so we can see the magnetic fields are going in this direction, so we wrap our fingers in that direction, and the current is therefore flowing in this direction. And this is our magnetic field. Okay, here the magnetic field is going in that direction. We use the right-hand rule, and we see that the current is going in that direction, and this represents our magnetic field. Okay, for this one here, we say, okay, well, where is the, we use the right-hand rule, and we figure out that this would be a dot. So it's coming out of the page. Out of page, and that's the current flow. Okay, and this one here, we point our thumb into the page and wrap our fingers to get it to go in the right direction. So we know this is into the page. Okay. Let's try the next one. All right, these are, we're going to come back to this one in a second, but we're going to wrap up the other ones first, okay? So this is when we have situations where there are solenoids, and we haven't learned about solenoids yet, so we're going to do that after the fact, okay? So we're going to come back to that in the next video, but I will practice this question here. So some more examples. All right, so here we go. Into the page, thumb points into the page, and then we basically take our fingers so we can draw. Oops, I've got the small one on. Okay, that's fine. So I just draw a couple. And if it's into the page, it's going to be pointing in that direction. Coming out of the page. Whoa, that's really bad. Be going in that direction. Okay. Here the current is flowing this direction. So we point our thumb in that direction. Our fingers would curl therefore from the back to the front, like that. Now, I usually draw mine like this. I find it easier, but it's the same exact thing, right? Except that's the wrong direction. So let's erase that because that's not correct. That here is not correct. Okay, part of it was correct, but not the other part. So again, the current is going in that direction, so that's our current. So the magnetic field is going, it's wrapping, basically, to draw it, it's got to come from the back around to the front, from the back around to the front, from the back around to the front. Okay, next one. So these are tricky to draw at times. All right, here we've got a magnetic field. We use our right hand rule, curl it, and we see that our thumb is pointing up in this case. Here we wrap our fingers. Oh, that was a trick. It's also pointing up because it's actually still going, in this case, the counterclockwise direction, and this one is also going counterclockwise direction, so therefore it would be like that. All right, here we go. We've got this magnetic field. We wrap our fingers around, and our thumb would be pointing to the left. And so that would be our current. And this represents our magnetic field. All right, the next part is, again, solenoids, and we'll come to solenoids in the next activity once we learn about those.